Hello, good day. I hope you had a nice evening yesterday and hope everybody enjoys their day and hope only the best wishes. We're going to code today. Oh no, we are not going to code today. Today we only have some easy tasks. What am I saying? The first task is coding. Okay, today we're going to adjust our peasant fact here, this one. And what the first thing that we want to do, we have already set up his animations. So the first thing that we want to do with this guy is we want to give him a new attack animation. Like now, he's working like this. You see all these little dots here. When he's walking around, only these 3 dots, you open the character. These three dots here, they are the points where he will deal damage when he's walking around. It means like in Super Mario, don't touch him. If you get too close, he will deal damage. But I don't think that this is a good idea, because he's the first enemy that we encounter, and I want to change this. So what do I want to change? I simply want him to have an attack animation, and he's going to have a forward swing. Then he's going to check for the attack. This is commonly called attack point in his animation. If the player is there, he's going to deal damage, and he's going to return his fork then, and that is his backswing. So we have to set up his animation, which must be, oh, it's the first one. Here you see this melee attack animation, and we can already guess where his attack point will be. See, it's 0.917 seconds, so his attack point will be at 0.4635 seconds. Okay, so just in the middle. It's just in the middle. I think we can just say 0.45, because you see when he's animating, he's going through these individual sprites. Let me show you. Here, this is the wrong one. This is the one. He's going through these individual sprites, and at this point here, I think it's here. I think this one is the point where he has extended his fork furthest. There's where we will have to check for damage. And then he has 1, 2, 3, 4, 5 more sprites. So he's going through 5 sprites. And his 6th sprite will be his damage point. Then there will be 5 further sprites. We can exactly calculate that the attack point is matching his animation, but it won't be necessary, because if we just do it in the middle, we're only going to do one check. We're going to be exactly at the right sprite, and that's it. We don't have to worry about much else. Also got myself some nice tea. I think it's a little bit too strong, the tea, but whatever. Tea is nice, very good for your body. It's just water with a little bit of nutrition and no calories. So what else do you want? So let's look at our to-do list. What we will do after that, because today we are streaming a little bit earlier. I have been taking my time with eating, actually. Been eating since I think about 15 o'clock, 3 p.m. and I just took my sweet time there. Just really disappointed in myself that I took so long. I wanted to stream before 4 p.m. but whatever. Okay, let's see. Now the next things on the list are just the difficulty setting, try out heartbeat movement, this is what I'm really excited about, and try out bloom effect for black background attacks and torches. All these tasks are smaller tasks, but from experience I can tell smaller tasks tend to still have sometimes some unpredictable difficulties or subtasks that you don't see beforehand. So I can't say if we can do those four tasks today, but I hope that we really get 2 tasks done and we'll have started a 3rd task today, because on Saturday and Sunday I might be on a tournament. It's not clear because we're not gonna have enough people. I was also a little bit surprised to see that this week and the next week and the weekend I'm going to have 2 tournaments, and these are the last one for this year. So I'm definitely don't want to miss them. And on the other side, we don't get enough people from our team. It's kind of hard. Now, let's start coding. So to get this new attack, we already have a guy in the game who does exactly what I told you about his attack. That's the bandit. The bandit also has the same kind of attack, so we are going to go inside of his script and look at this enumerator. You see, it's really not much code. It's going to play a swing sound, then he will attack, and if he after waiting for some time, he's checking if he hits a character, and that's it. That's basically one of the most basic scripts that you can do. There's really not much to say about that. So let's copy it. Gonna correct some code here. And now we have this. Let's because we have a top attack, we also want to differentiate this attack from the other, so you can definitely tell them apart. I'm going to call this then the front attack. If one is the top attack and this is the front attack. Okay. Now we still don't have this front check, and we don't have the push force. Okay, we don't have the sound, and this attacking state is missing. So let's first check how the old script is handling the top attack, because the top attack works similar, just on top. Okay, let's see where this is called. I don't see it. Don't see it. Okay, now let's do what I should have done from the start. Find usages. Okay, there it is. It's in. This is the fixed update function. Okay, not too happy about that. Oh no, and this function looks very complicated. So it simply sets a boolean on top to true, and I guess if on top is activated, yes it is, then we will not do anything. So let's rename this to attacking. And also use this new boolean for our new front attack. Okay, the old name was already attacking, so we already have taken care of that. Now we have to call this method. So we are going to look for the top attack. I already forgot where it is, but I'm going to find it. I'm going to find it. Here it is. This is the old function that is damaging the player. And you see, it's just checking if the player is next to this damager check position. And that's it. That's it. So we're going to extract this, put it in our front attack, and just put it there. It's not that important, but I want to look at the code later. Let's go to putting in our code inside of this character. So for this, we are just going to copy this, and we're going to check for the front attack first, and the top attack is going to be the top attack is going to be the second check. So there's a damage check. There are 2 damage checks, and we have to look up what they mean. This is number 1. Number 1 is more extended. Okay. So we have to look at number 1. Number 1 is the far away. Actually, we can look at both. We can look at both of them. So the player is in front of the fork or is directly in front of the peasant. We're going to trigger melee attack. Okay, now we're just going to trigger the front attack. That's it. That's it. And actually, we don't need to call to set attacking to true twice. It's already in the attack. Let's put this into the top attack. Okay, now this swing sound, we don't have the swing sound, so we still have to do this. Let's put this into our little sub-step to-do list. Make swing sound. So we don't forget about this. This is why smaller lists are very important. Even when I was working at web security at the job, I always did take notes to make sure that I don't forget anything, because especially in programming, after some time you have so many tasks that it's hard to keep track of them. So that's why you always need to take a lot of notes, because every task is divided in so many subtasks, and if you're not used to that, I'm used to the environment here right now. But if you're just getting into your new job and have to learn new schemas, patterns, then you have a higher probability to just forget things. And it's always good to not think of yourself as smart. You're smart enough, but be smarter and think about and also think about your own shortcomings. So if we are going to set his trigger, make his front attack. I think this is melee attack. I think this is named melee attack. We are going to have to check this out. Okay, let's go into the animator and look into the peasant. Yeah, it is called melee attack. There is something that this state says has to be fixed. Oh yeah, we still have compiler errors. Yeah, we still have compiler errors. The wet code was here. We have to fix them first. It just tells us don't work on this stuff before you have to fix those words. A little bit weird that it complains about the compiler stuff there. Of course, they are a separate system, but fine. Let's keep doing that. So, first of all, we could just use the old hit function, this hit function. It was activated the whole time, and put it in here. And you would just have to set up the swing sound, this sound. So we are going to do that soon. Set up a swing sound, and we're done. Yeah. And the only thing that is not good about this code is that the push force, this push force is not delivered, but aside from that, you can just use this old code, put it in here. This code just checks for them is the player inside of the fork that the peasant is using as his weapon, and after he has extended his weapon, then there's going to be a check. The check is going to see if we are actually attacking the player. Yeah, that's it. Nothing more. We are going to instantiate a hit effect. That's nice. Play the hit sound. Only if the player is hit. Yeah, I think that's ready to be tested. We only have to set up his sound. We are going to give him a placeholder sound first, and I'm going to get to the bathroom real quick and make a short break because, well, you gotta do what you gotta do. See you, and then we are going to set up a sound. Okay, I'm back. Setting up my headphones. Okay, so now I've set up the character. It's a character script, not the character. We still have to set up our last sound. We're just going to copy this sound here because this is also a sound that is sounding very similar to what we want to have later on our end product sound. So let's try it out. And see, and look for potential bugs. Okay, there's a big problem there. Okay, two problems. First I want to get rid of the peasants right here. They're annoying me a little bit. The first big problem was his animation sprites did not match his overall height. I have to fix that. I already know why, but I'm going to show you later. The second problem that I saw, and I don't know why, is he did not do any damage. So let's first fix his animation because that is easy to do. So we are going to open the sprite editor. We see these are his animation sprites, and I'm pretty sure that if I open another sprite set, yeah, you see this blue circle here? They have a custom pivot point. So the center, which is this blue point, is not in the center of the picture for some reason. I think I tried out some animation and then I did set it up for some reason. I don't remember why, but it's easy to fix. Just set the pivot point for all these animations, and that we can just reslice the sprites here. They are 275 pixels wide and high. I'm going to set a custom pivot point, and I think it was 0.406. Let's try it. Oh, how can we do this for every sprite at once? Yeah. I don't want to go through every sprite at once. It would be a little bit annoying. Okay. Slice. Looks good. And apply. Now let's check if the animation still works. It seems to work. And play it in the game.
Hey!
Yeah. So now he's not changing his height. The only problem is he's not doing any damage. That's not good. So what's going on here? Ah, I see. He's going to use a layer mask for where the player should be. I think this layer mask has not been initialized or been initialized the wrong way. So we have set it up to be the player, this line of code. So first let's just set up this layer mask. I don't know where some code might change the layer of the layer mask. Layer mask is just saying it's a mask, and everything that on the mask is what we want to detect. And the layer mask has not been set up here in this front attack. We want to set up the layer mask just before we use it. Here's the layer mask, and layer act is the player layer, and we only want to check for the player layer. And oh, there's also a boolean, and I think also this is a problem because this boolean attacking was that to be checked if it is false, but we are attacking, so this will always be false. So I think this is the real reason. I think even the layer mask, I didn't see that it was not set up, but I think the layer mask would have worked anyway because it's only going to set up in the code to be for the player. But it's better to put the layer mask code here in front of the right where we need it. For some cases where we want to detect if the character is standing in front of walls or if he's going to hit an object, then we want to write an extra function for that actually. And we still have to do this. Let's put it out to our substeps. Damage objects. Okay, right now we are only checking for the player, but we have forgotten that this character is also capable of destroying objects, and we have to look into that. Right now, if he's running into an object, he's going to destroy it immediately. We don't want that. We want that he's going to play his animation first.
Ah!
Yeah.
Yeah!
Yeah.
Yeah!
Yeah. 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 Okay, there's an animation problem. Yeah, she's set to idle after that. To fix that. This animation, we did not set up his animation times. So as I said, his animation times is 0.917 seconds. So the middle of this is 4.635 seconds. And we are going to wait this 2 times. Then together they add up to, oh no, I miscalculated there. It's going to be 4585 seconds. Miscalculated there in my head. And if we add these two together, we should have 0.917 seconds. And we want to add some code because of his running animation. We want to stop his one sound. When he's attacking, because he has a one sound, which are his footsteps. You hear them on the ground. and we want to stop the sound. And when he's finished with his attack, we want to loop. Play this again. Play delayed with the. Come on. Can you please give me the right function? Okay. Play this delayed with a delay of 0, so immediately. Then we have to set up the one animation. So let's see where we did set up the running trigger. Okay, it's one fast. Interesting. Okay, now we want to damage objects. There is already some code here to damage objects. So, as usual, we're going to copy this and put this into our front attack. Okay, make some spaces so I can find it later. Later we have this unedited code. Forget about the code. We still have to set up something else, and that is that we have to detect when he should the peasant, when should he attack objects. And there was also another problem. He was running into the player way too fast and then standing nearly inside of the player when he was attacking. So when he's going for his front attack, we don't want this. We want him to stop his velocity and stand still. So we are going to give him a new vector too. If he's we want to set his forward and backward velocity to 0. And if he's falling, or if he's jumping, we want him to not lose that velocity. So we are going to read that velocity out that he's using on his y coordinates, which is his height, which is going for up and down. We want him to still use this for his velocity. So we are only going to set his x velocity to 0. Now, could there something go wrong? Yeah, if the player pushes the peasant, he's going in this moment to 0. Or if something else pushes the peasant, it might look unnatural. I think we could fix this by applying a velocity against his current velocity, just like add force. But this would really need some time in testing to make the system foolproof, because they could also backfire. So I think this is actually a very safer way for the moment, because I don't have a system set up to set his velocity to 0 in a safe way. For the player, there's a better system. The player has certain variables. If he's pushed, he's never you can just check if he's being pushed around by anything, and then you can just say, okay, if you're pushed around by anything, don't do anything. Don't change the velocity. But enemies currently don't have that, and I don't think I will add it. It's not that important. Except if I see this in testing. So, where was I? Yeah. So, we're going to first, don't need this if clause. We are going to remove it. Okay, this code here is really weird. I'm going to copy the code for our normal attack and just set the layer mask to 14. So he's now checking if there's an object. Okay, first, this line of code is not bad, actually. Because it checks if there's objects, and it could be multiple objects. We just have to adjust its parameters. Okay. It can only take one of these masks. So we have to do this for 2 positions. Okay. Now we want to check this in 2 positions. So let's try to add more calls. So how we're going to do this is, right now we are setting up an array, a calls array. And the best way to do this would be if we could make this into a list. I'm not sure if a list, if it's if we can do this directly as a list. Does this work? No, because this is going to give us an array. We have to convert it. Oh, okay, we have to convert it. So instead, we can we need to make 2 calls arrays, which is not ideal. It's not ideal. It's not actually what we want. We're going to, because we have 2 positions that we want to check. And then we need to add both arrays together so that we have all the detected objects that might be in there. Now, in 99% of all cases, this is going to be just one object, but we have to still have the code for 1% of the cases. So let's look if we can just add the 2 collider. Don't want to read them out. Okay, we cannot just add them. I have to actually Google this for once. C# add 2 arrays. Okay, let's try this code, which is quite easy to reuse. Okay, we are done. We are done. That's easy. Now we have all the colliders in one array. That's nice because now we don't have to program 2 for each. Now take our for each. And for each collider in this array of colliders that we have just created, we want to look if there's object stats. This is really old code, by the way. And just check for this. Yeah, and then we want to attack them. And we are also going to instantiate our hit effect and our hit sound if we hit anything. Okay, that's it. Now we can also attack objects. So let's compile this and place a loot box, a crate, in front of our peasant. That does not seem to be the loot box. Yes. It's not a loot box. There's no loot in there. It's just a crate. But I'm way too much used to loot boxes, so not for my games. I don't do loot boxes, by the way. It's just a common term today. Okay, let's test out if the peasant can now destroy this loot box.
Ah! Yeah!
Okay, he jumped over that. That's clever.
Yeah! 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 Yeah!
You have an idea? Let's
Yeah.
wait for him to attack. And now put the loot box in front of him. And later we will decide if we actually want the peasant to jump over objects or if he should destroy them. So let's put the loot box here. The crate. It's a crate.
Yeah.
Yeah, he destroyed it. So our function works. Very nice. So yeah, no bugs here. No bugs. We only have to set the sound and decide if we should jump over this crate or not. That's a good question. So let's yeah, has a pros and cons. So in the game later, now this is a test level. So this is just a test level. So this does not look like the levels later at all. And in the real levels, there's sometimes there's 3 crates stacked. And the player might try to use them to his advantage. So what would be nicer for the player is it if the peasant goes to the box and destroys the box, or if the peasant goes to the box and jumps over it. Don't know the answer yet. It's really interesting. I don't have any good arguments in either position why one should be better than the other. So let's go through. If the peasant destroys the box, the negative is the box is gone. You can't use it anymore. The positive is the peasant is losing more time because he has to hold, and then he's going to play his attack animation. So he's using 10.917 seconds. This is a total attack animation time for his melee attack. When the peasant jumps over the box, he's going to lose less time. He's still going to lose some time because he has to land again. I think you're going to make him lose maybe half a second, so 0.5. But you can use the crate again, and the crate is not going to be destroyed. The problem is I like both ideas. I like that he's jumping over crates actually. I really like that. I think I think that's not a bad idea to let him jump our crates. I think for the moment, we can let it stay like it is right now and change it later when we come to testing. I think it might be better if he jumps over the crate because you would continue to pressure the player. You would continue to pressure the player and you can reuse the crate or whatever object there is because his crate and box algorithms are generic for any object. So the second thing that I had the feeling like you were not hit every time that you were standing in front of him. So I'm going to increase his damage check radius a little bit. Now let's try again. And see if when he's running towards us, if he's hitting us. It's also something else I want to check. When the attack is triggered. There. Okay. Wanted to check if the check radius is smaller than the attack damage radius. Okay. Okay, it's really easy to. It's really easy to dodge this attack. This is a little bit too easy. Okay, so let's look at this guy here, and let's look into his damage checkers first. And when he's going for the melee attack, we have to look into sprite 5, I guess. Okay, we're checking at damage 1. Again, checking at 2. But what is this point? This point should also be checking if you do damage there. And this is a flip check. Okay, so let's first reverse our changes on the peasant here. So let's also add a check at the flip check. First, we are going to see if they trigger the attack much faster by also checking if the player is next to the flip check. And we are also going to check if the player is standing next to the flip check when we are checking for damage. Okay, now next thing is, because it was too easy to dodge this attack, we might want to decrease his total animation time. To have this to be roughly around 0.2 seconds. Because you saw, if I was running away from him, he's never going to hit me. It's more than easy to evade this guy, actually. This is next to impossible to die to him now.
Hey! Yeah! 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 Yeah!
Okay, now the next thing that we want to do is let's try to not stop him, so that he maybe slides into the character a little bit. It is going to increase his difficulty. It's the first thing that we can try, and if even that is too easy, then we can also change his total animation time.
Yeah! 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 Yeah!
Okay, I absolutely think it's too easy. That's way too easy how to evade him. So let's decrease his animation time. How are we going to do this? We are going into his animator. We pick his melee attack right here and just double the speed. Now his attack will be played twice as fast. Twice as fast. So we are going to use this time. Now, how much is this divided by 2? I'm too lazy to calculate that. Let's just pick a calculator. Old school style. 0.8585 divided by 2 is 0.22925. Okay, and this will be our new damage point. Okay, and here we go. So he's the first enemy that the player can encounter, so he should not be too hard. But he should have at least a chance of hitting the player. He's no challenge at all, it's too easy.
Yeah! 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 Yeah!
But we still see that it's still easy to evade him if I just keep moving.
Yeah! Yeah!
But he's at least trying. He's trying.
Yeah! 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 Yeah!
We have to adjust his sound a little bit. Because if we trigger it as much, he's going to overlap with his hit sound effect. Swing sound. This is his swing sound. This swing sound is a little bit loud right now. The current sound is when he's is just a placeholder for the time when he's going to attack on his top. So what are we going to change? We're going to make our new hit sound. So for that, let's open Audacity. Now you have this old sound maybe in mind. This is also a good starting point. Let's listen into this again.
Yeah! Yeah!
Now this has two different properties. One is the sound that the peasant is making. This yeah, yeah. The second one is a clong of his fork. And we're going to make the same sound again, but it has to be in 0.22925 seconds. And we are going to make it a little bit less noticeable. A little bit more silent. Not too loud. But we can adjust the total volume in Unity later on. So let's not make a silenced sound in Audacity. We're going to adjust the volume later in Unity. So first I'm going to make the peasant sounds. Yeah. And this guy hears a very, very rough noise. Like he's a guy who has been working the fields for a long time. I have a sheet for characters. Let me go for that first. And in this sheet, there's information about their pitches, like how low or how high did I pitch these guys. We find it. Doing that on my second monitor for security reasons. Here, there's an Excel sheet. And the peasant is not under them. Okay. Okay. Now let's then we have to improvise.
Yeah. Yeah.
Okay, I think that was a little bit too loud. Let's just play these sounds first. I have to adjust my volume because it's too loud in my ears.
Yeah. Yeah.
I think that one was nice.
Yeah.
Not too loud, too loud.
Yeah.
Okay, we have to do it again. And this time I'm going to turn down the volume of the microphone.
Yeah. Yeah. Yeah.
Okay, let's listen into that.
Yeah. Yeah. Yeah.
So I like this one because this is fitting all the criteria that I just defined. Let's filter out some noise though. The noise is pretty much my PC. My PC is unfortunately a little bit old and it's too loud at the moment.
Yeah.
And also like this sound. I think it's inferior to this one.
Yeah. Hey.
Oh, I like this one. I think this one is superior. Let's copy that into a new track. I think this one is even more superior because it's a little bit slightly more clear. Okay, that's it. So these are all the sounds. So let's listen to them one last time. Okay, let's look how long they are. So this one unfortunately seems to be a little bit longer than the others. A little bit over 0 to 5 seconds. Because a quarter of a second is when his attack will hit. I think it's fine. I think this is fine. They're all in a good space. They're all in a good space. Yeah, I want to go for this sound. I think this is just the same sound as this sound, but it's just a little bit more clear. So let's amplify this. Okay, there's still some noise that I can hear. Let's try to filter that out. Yeah, okay. And now we're going to make the fork sound. So for the fork, we just need to have some slight clong. Would it be realistically that the fork, if he's going to just use it and attack with it, that it would make a noise? No, it would not make a noise at all. But we are still going to give it a small indication, because this alone here is not enough to indicate that the peasant is attacking. This is just, okay, he's making a noise. We have to also give the player a hint in the sound what he's doing. So that's good for his readability. For this, I have the perfect subject for making clong sounds here. I still have to find something to beat this. Okay. And now we are going to make some fork sounds. What are our criteria? It should not be too. It should be not be too loud. It should be fast, and I think it should. I think we should hear two clonks in this, because the fork is the fork has 3 stabbing zones. I don't know how to explain this. Like, if you have a fork at home, they sometimes have these pins at the end of the fork where the actual stabbing part is deployed, and that's if that's a little bit loose, it's actually really making a noise if you stab it. So I'm going to try to imitate that. Okay, that was not on the track that I intended for. Sorry. Okay, I still have no idea how these sounds will be working. Let's go for it. Let's listen in. Okay, these are not loud enough. Not sure if I like this one. And let's also noise filter them. Oops. Okay, reduce the noise. Let's keep listening. Yeah, I want to copy this just as a maybe. I don't know why I like this, but I want to copy it. This one is interesting. So there's a lot of interesting sounds. This one sounds like it's a really weak attack. Okay, that's all the samples that I want to try out. So what we are going to do is we want to put this as a solo sound here. And now we are going to try different of the fork sounds. For that we are going to amplify them first. So they are roughly the same volume level as the exhale sound from the peasant. Then we are going to play both together. And let's see which sound we will pick. No. No. Yes. So let's straight up delete those two. Think this is inferior to this. Okay, and here comes our duel. This sound or this sound. Now let's also think what would be the perfect timing for this sound. I think this sound is played too early. Should be the high point of this exhale sound. This sound here seems to be at the correct position. Can also play both the sounds at the same time. Doesn't seem to make too much of a difference though. I think this sound here. I think this sound here is excellent. So let's make this our second part of the attack. Sound. So these two sounds, this sound and this sound, are the winners. Let's amplify this a little bit more and play. Let's try what happens if we play it earlier. Not sure about that. Okay. So this is going to be our Sphinx sound. I'm going to export this. It's an MP3. And choose the white folder. And after that, we are going to export this to Unity and see how it fits into the game. Okay, let's go into the game. I'm going here for the sounds folder, the peasant, and just drag in our new sound. This is our new sound, I guess. Let's check it out. And we're going to give it to the peasant. Okay, let's check it out.
Ah!
Okay, I think the exhaling sound is too loud. Also, this sound here has small echo. We can't do anything against this, except maybe trying to filter this, but there's a high risk that we going to make this sound dull. Let's nonetheless try, at least. And that didn't sound too bad. I also want to give it less volume. Just slight. Okay, and we are going to overwrite our old file and re-import it. So how are we going to re-import it? Just show this in the Explorer here. This is our old sound, and we are just going to drag and drop this new sound that we just made into the folder and overwrite our old sound. So now Unity has just checked that this sound this sound, sorry, has changed. And let's try to play this again.
Lane.
That's bad. But I think it's too repetitive. It's too repetitive. So the best thing that we can do is give him a second sound and then let him switch between two sounds randomly. The bad thing about this, why I don't really like it, is now the player won't be easily distinguishing his front attack and his top attack. His top attack is when you jump on his head and try to stand on his head, he's going to take his fork to the top and attack you there. That's his top attack. And this is a different sound, and it could get harder to distinguish those two. Nonetheless, we have to create more sounds. We can't take just this sound. It's playing too frequently to just take this sound. So first, I'm going to pitch this and still export this, because I have the feeling like it didn't match his voice too much. Like, I think his voice is pitched slightly. And now we are going to create a sound out of my second favorite choices. Apply all our filters here. Okay, and we're going to make this our second sound. And then we will have to adjust the code that we are going to read both sounds out. And depending on the situation, we want to pick one of those two sounds. So first we are going to overwrite our old sound here with the new one, which has slightly changed. And we are going to import our new sound. Peasant is going to get a new audio source. Now you can do this differently if you, instead of copying this component over and over again. Oh, his spatial blend is not set to 3D, which is very bad, very bad. Should always be set to 3D here. This is if you can hear where the sound is coming from. Okay, only his hit sound should be allowed to not be 3D. Because you're hearing the hit. If you're hit, you are hearing it on your character and not at a special point. And you want to feel like you're hit. So. And we have copied this swing attack here. We're going to set it up to is our second swing attack. Right to the prefab. Now we have to initialize both sounds. So let's rename this to swing sound 1. The second one will be, well, what could it be? Swing sound 2. And this will be our next audio source. And you could also apply them as a clip to the script. And if I would have set up a system for sounds, that would be 100% better. Now we have to see where did we play our swing sound. Find usages. There it is. Okay, now instead of playing swing sound 1, we want to use random. I think Unity random. Just go for random. Can you just import it, please? Okay, random range. And we want to have a range with integer 0, 1. I have to look it up. I would have to look it up later in the API. We need to initialize an integer RNG. This is just a random generator. And if this is 0, let's make this a switch case, because there could be even more cases here. Case 0, break case. Let's just define. Case 0 is you play the sound, and now case 1 is you play the other sound. Yay! Now we have to look up random range, what is included and what is excluded. When we are using integer. So it says the first one is inclusive, the second one is exclusive. So it's never going to be 1 because it's excluded. It's always going to be 0. So we need to set it to 2. And we would always have this value to be set to 0. That's why we need to look into the API. Okay, now let's test it out.
Lane.
Okay. I think we are finished with our work on this animation. Now, there's one thing I have forgotten that I wanted to do. As usual, there's one thing that I forgot. I wanted to keep the old code. I wanted to keep the old code for a special case. And this case is, do we have the global variables initialized? No. Let me start programming first. Private global variables GV. Now we are going to find the global variable. Okay. Now what we want to check is if the difficulty is, I think it's 2, is hard, then we do want to execute our old code. And if the difficulty is not hard, we are going to use our new defined attacks. The behavior that we just saw from the peasant is his behavior for the normal mode and the easy mode, where you want the player to just learn the game. You want the player to just learn the game and not to be pressured at level 1. If the player says, okay, that's too easy, I'm going to set the difficulty to hard. The old behavior is much harder, because in the old behavior, you're running in front of his pitchfork and you get damaged immediately. So let's re-import his old code. I actually have some older copies of the game. I'm going to browse them right now. But this should work immediately. Oh, hello, Sisa. Sorry that I didn't see your chat message. 3 to 5 different sounds for this is attack speed. 2 probably not enough. Yes, actually I agree. More is more. Definitely better. But it would slow me down too much, and I have to get my tasks done because I don't want to make this game forever. I think on the other side, what I just explained, if you have different types of sounds for different types of attacks, less is better, because then you can distinguish the type of attack from what you're hearing. So here's a top attack and a front attack, and when you hear the sound for the top attack, you know, okay, this is a top attack, and when he is doing his front attack, you know, okay, this is his front attack now, and you immediately without seeing what he does, know what he's doing. That's why less can be more in this case. So I think 2 is enough. And if I would record even more sounds, I would have the risk of the player not being able to distinguish the sounds anymore. So there's a logic behind that. Aside from that, I could just mix up the sound samples that I have and make 3 more sounds out of that. That's not a problem. I also have the code for that now. I say 15 minutes and I'm done, actually. So yeah, it wouldn't be too hard, but yeah, the problem in the end would be it might be hard to differentiate for the player then. What is the figure doing right now? So, okay, I'm trying to get my old code for the harder difficulty. And I'm browsing on my second monitor right now. That's why you can't see anything. Okay, this is the old code right here. I opened the old code now. It's from a safety copy of the game. And what I need to do is just copy this code. This is what we modified. We check again. Yeah, this is what we modified and put it in here. As just this flip check, which is going to the character will turn. This is checking if the character should change the direction he's facing. Okay, now we have 2 different settings for difficulties. Now we have to find out how we actually are setting our difficulty. I think at the moment the difficulty is set to normal. Let me check that out.
Lane!
So the current difficulty is 1. So we now know the difficulty 1. Let's check which difficulty we are using. We are using the normal difficulty. And we can pick hard or easy now. Let's pick hard. And look at our global variables. Hard is difficulty 2. Okay, let's see if he's using his old code now. Okay, immediately destroying things, attacking us. Okay, let's switch our difficulty to intended, which I'm going to rename to normal again. And he's immediately changing his attack mode and is a little bit easier. So that's nice. And that concludes our work on the script of the peasant. He does not do auto damage in his melee form anymore. Instead, he immediately just attacks. It's great. And we have done our first task for today, and we are closer to deploying the big patch that I'm talking about for weeks now. But the next tasks are actually quite as easy or easier than this one. So let's pick our next task. It's a little bit hot in here, but I think I can still bear wearing a little bit more. Okay. This is for the UI. This could take some time. This is difficulty settings checking and only coding. So interesting. I think I'm more in the mood to adjust the difficulty code right here. Because once we do this, we won't need any more coding for the rest of the task. And we have the code editor opened. Can close the sound editor now. On the other side, these tasks are also very interesting. But for them, for this one will be include me opening a Unity example project where they move with shader graph all the trees and bushes in the backside. And this is really amazing to see, like, just how they do it. And they do so much stuff with their shader graphs, which I can show you right now how they look like. Let's just jump into the shader graph. Yeah, this is one that I did set up. This is one of the shader graphs. Let me put this into a new window. When I work with shader graph, I always open it this style. There's actually a shader graph there where I wanted to change something. I think it is this one. Yeah. And this one does that as an effect displayed over your blood when you see the blood UI. And for this one, I wanted to change the direction that this graph is moving. Not the speed, the direction. Okay. I put a minus in these two. Going to move in the other direction. Yes, it is. So now you should not see any pattern here. What is actually going on? This is what I'm going to obfuscate. You see this pattern? This is a random pattern that I created with the shader graph. But you can see if you would just play this over your blood UI, which is going to be shown if you take damage. then you could not see, then you would immediately see what is going on. There's little points going around here and there. You would immediately see the pattern behind that. And for that, I'm also going to display a gradient noise pattern, which is circling around very slowly. And I'm going to mix those two up so that they obfuscate their direction. And this pattern right here is actually circling around too. It's really slow. Now I changed the direction of those two. I think you can still see a little bit what's going on. You really pay attention, but it's okay. I also wanted to make this a little bit darker by clamping it a little bit. So this is what we get, and I think the break parts are a little bit too strong. Okay. But that's just a small improvement that I wanted to do. Let's close this now. So I think we should do the heartbeat beat movement. Because on the flip side, the difficulty setting, it's going to be a very dry topic, and I think that I'm going to do this maybe later. I'm not even sure if I want to do this on stream. Maybe it's, yeah, why not? But I'm going to do this later because it's really a dry topic. It's just adjusting some numbers there, some if clauses, and that's it. So let's try our heartbeat movement. So what is this? We want, first let's show what I mean. Why did I do this task? We have in our UI this heart right here. And you can see there's some blood pumping inside of it. And this is some shader graph. It has its own shader graph attached to it. And we can see our blood UI here on top. And what we want to change about this heart is that we want to have a real beat with it. So we really want to see our blood pumping with this heart. And for this, I'm first trying to look into a YouTube video YouTube, Unity, last, I think script is the last script. Last script is the Unity example for this.
This is going to be a session.
This is a tech demo. And inside of this tech demo, we can see that they are moving these trees around. Let's only pay attention to the trees. So this is done with shader graph, and we can also do this. Let's look into a shader graph if they show how they did this. So now they're trying to show a lot of trees. No, it's not what we want. This is what we want to see. And actually, we don't see too much here. See some noise. And they don't show the whole graph because I think it's too much for the tech demo. Okay, but that doesn't matter because I have the project on my PC right now. I've downloaded it already. So let's open it. So we can close the editor. Don't need this anymore. Close all the Excel sheets. We also don't need the voice settings. We did this, all these subtasks for the peasant. Now we can just go into Unity and look at this demo version of last script. And I don't see this right now. Okay, so I have to find it. I maybe have to download it. Let's look at the assets. Ooh, okay, that's exactly what we don't want to do. We don't want to open this in our current project. It could actually kill our project. Now I have a safety copy. I think I did my last safety copy Monday, so that's no problem. But we want to do this in a new window. So how do we do this? It's a download. No. Might just close the window and look what happens if I now try to open it. Hopefully it does try to make a new project now, but I'm not sure what he's going to do. Okay, something happened. Nope, didn't work. So I can try if I can find the demo on my PC right now. Yeah, I found it. And now let's open the project. So, while loading, it's time for some wonderful, wonderful tree, I guess. Because tea is the best. It's the only thing I remember. It takes a lot of time for this package to open. It's a demo, but it's a big demo. I'm looking up how big this demo is, though. One 1.3 gigabyte. Okay, this should not take too long. In the meantime, I can put aside some of the stuff that I got out for the last sound that we made. I can switch my headphones because I'm always switching between those two headphones. When I'm after sometimes these kinds of headphones are just starting to hurt. These headphones here, they're also really old, and they rest a little bit on the ears. After sometimes they're also going to hurt. So I'm also always switching between those two when I'm streaming for a longer time. When I'm not streaming, I'm listening to normal sound boxes. So then it's not a problem. And from that, I can check that I changed the stream description because we're not doing the main character facial expression right now. Improve player UI. That's our current task. And I can also check if this is stream number 19 in English. I think I've forgotten to set up the bar last time. Yeah, this is stream number 19 in English. So at 1. Okay, let's see. The materials in your project were created using an older version of the Universal Rendering Pipeline, URP. Unity must upgrade them to be compatible with your current version of URP. Unity will re-import all of the materials in your project, save the upgraded materials to disk, and check them out in source control if needed. Please see the material upgrade guide for the URP documentation for more information. Okay, it's important. It might mean that our materials will not work immediately. So let's look at this. Oh, this looks like it works. Okay, is it working in game? Seems so. Let's play the demo version, just to make sure that there's no compiling errors and that every material is set up correctly. Okay, no cloud project ID found for analytics. We don't need analytics. So if we stand right here, we can see that the leaves of the trees are actually moving. And this is done with shader graph. And to replicate this, we will later look into the shader graph and see how they do this. Now let's go through the level a little bit and just look at how they did set up things. And also because this is a very, very well done demo, let's do this in maximized. Okay, I think that's it for the demo. There's a lot of beautiful stuff right here, but there's not much that I don't understand anymore. I think the only thing that I need to learn is how they do the movement on the leaves of the trees, which are done beautifully. Okay, so let's look into the material of the trees. So for that, we are going to try to get the trees. Environment, middle, exterior. So they've done multiple layers for the trees. Nothing that would surprise me. Now there's tree group. Let's disable this. Okay, this is the whole tree. How are they doing the vegetation? Okay, here. We see there's a material, vegetation, wind, or lit. Let's look into that. I want to look at this middle part, this one. Okay. And let's look into the shader graph, what it does. Okay, now we can open the shader graph. This is the shader graph that we just saw in the YouTube video, in the demo. And let's look how they do the movement on the leaves. This stuff here seems like they have this looks like this is maybe the normal map. Yeah, this is the normal map, I guess. Then there's is this a mission? This is a normal texture. Okay, this is stuff that we don't care about. Let's see where they do the movement. Okay, calculate world UV scroll direction. And they have an input for wind direction. And I've set this up to set this up to 20. Now we see that the wind is over the top immediately. So we see that we have found what we are looking for. Let's see how they did this. Now I think first they... No, I don't... They do something with the tiling right here. Let's look what this wind scale does. This is just adding noise. I think the preview is broken. Yeah, I think the preview is broken for some reason. So let's not save this and open again. Yeah, some assertion failed there. So I think it works like this. They have a wind direction. It's coming from one side, and then they add a lot of noise to that wind direction. So you have a two-dimensional graph with a lot of values for where the wind is coming from. They apply this noise on the graph, so you don't know where the wind is going to grab the tree. This is how they did that. So let's look at the top path.
Caesar TV. This is genius.
Kind of genius. Well, the best part is, if I want to apply this to my own game now, I can just grab this, copy it, and put it into my own game. This is the best part of it. Now the important thing is I cannot just import it, I need to understand it. Because I want to apply this to my own, to the player UI. And I probably don't want to just randomly apply some noise to the heart. I want that it looks like that it is pumping blood. That is not easy to do. So they have a wind influence mask. And I have to find out what this is. This is a property. This is a wipe. This is a wipe position. This is just a float. This is not a mask. Okay. Let's see what this does. Let's put it into a ridiculous high value. Okay, we don't see anything happening. No, let's put it to a ridiculous low value. And the only thing that I see that the box here is putting out a different kind of a map here. So they set this up that the white is fading into black for the power. Then they use a clamp node, and actually this is a clamp node that doesn't do anything because it's set to 0 and 1. Oh, it does something. Every value that is under 0 and over 1 is going to be set to 0 and 1. So there's only values between those two numbers. If you, for example, have a value inside of this black that is minus 1, it's going to be set to 0. And you can actually go over 1 with your white parts here. For example, if you are going for bloom or HDR, bloom effects, so emission from light, you might want to have a value that is higher than 1 for bright parts. This is going to clamp this to 0 and 1. So this is actually doing something, yes. Okay. Vertex offset influence mask based on sprite's height. Does it mean? It makes a mask that is going to influence how the vertices of this sprite are going to be influenced. Yeah, it's going to set a mask how the vertices in this sprite is going to be influenced. This is actually a 2D object that has vertices, just like doing 3D, your vertices. You can do this in 2D, and I guess if they say so, this is done in this is imported as a PSB sprite, yes. And then you just set up some vertices. So if I set this to a very low value, we see that it is barely moving. And if I set this to a very high value, see only the outside parts are moving. Okay, interesting. Now they are combining this with noise of the wind. And apply it. So let's see what they do. They multiply those two. Add them to the real object, and they apply them to the transform. It's a legacy transform. Let's try what happens if we use the current vector transform. Would still work. So if we, instead of using legacy, we use the new transform, can that work? Yeah, it works as well. So we can, we could just hit update on this, would do the same thing. Yes. Now our main preview is fucked. Whoops. So let's reopen this. Discard our changes. Update. Okay, yep. So that wasn't a problem. And this is going to influence the position of the vertices. Okay, so what is this vertex mask? I want to take a look into this. For this, let's find what kind of sprite they use. Okay, this is a sprite texture right here, and let's open this in the sprite editor and look into the skinning editor. And here we can see the geometry of this sprite. This is the vertices. If you look at all these little points here, all these little points, these are the vertices that are going to be edited. Because this is a demo version, we don't really care what happens if we do this. Let's do this and just add some vertices in the middle part, and I have no idea what's going to happen now with the sprite when we're trying to set it up. So let's save this. Apply. And look into the shader graph. Now this doesn't look like much has changed. Let's maybe increase the wind speed. I don't like to change the wind speed. Let's maybe increase the wind strength. What happens then? Ooh, that's interesting. And the wind scale. What does the wind scale do? Okay, this does that's roughly the same as wind speed. Let's change the wind direction. Now this is going to make the wind much stronger. Could also set this to a minus value. Now the wind is hitting from the other side, pushing the sprite to the other side. Could also make it push up or down. Okay, and I would say this is enough experimentation. Let's copy this into our project. I mean, this is absolutely allowed. This is a free demo by Unity, and they want us to copy this. They absolutely want us to copy this, and we use their project and get some ideas out of it. And we should. This is how they want to explain people how to do good games, and that's why we are looking into that and using this as a guideline. So this is also, if you look at the game, this is beautiful. This whole game is beautiful. Also thanks to the good artists. So they have a really good artist that had the time to paint all this stuff. That's what I can't do. But aside from that, they're also using a lot of lightning effects and showing off how they do their particle effects and lightning effects. And there's a lot of that I learned from this demo project right here. And for everybody who is working with Unity or with Unreal or Godot or another engine, look, if you want to learn something after you found your grounding, your after you get through the basics, then you can look into their demos and try to understand them. And the first time I looked at this, and I saw what they did there, and I just thought, this is wild. I have no idea what they're doing here. Nowadays I do it myself. And my shader graphs turn out sometimes to be much longer than these ones. It doesn't mean that they're genius or something, but it's very easy to have long shader graphs just because you want to apply a lot of changes to the graph immediately. On the flip side, you have to spend a lot of time doing this stuff. So let's reset the wind direction. And I think, what did I change? The wind strength to a reasonable amount. Okay. And I'm still not sure how we are going to make this into a heartbeat. I'm still not sure how we are going to do this. I could cheaply just say we're going to apply this kind of movement that we see like now with the heart when we are taking damage, which would also be a good move. A great increase just for the UI. You want the UI of the player to look as good as possible, because the UI is the stuff that the player is going to see from the beginning to the end. So it's important in the first five minutes, which are the most important minutes in the game, because if your player does play the game, in the first 5 minutes he's going to decide if he wants to continue playing or not. And also, it's everything that the player that he sees in the whole game that has to be polished as much as possible. Because if it gets old very fast, it's not good. So let's look where the heart shader is. I think it's this one. Let's look where we did set up our graph. It's here. Okay. Now we see this vertex here. Oh no. Well, that might be a problem. We did not set up vertices for our heart. So we have to do that first. Our current heart sprite, we look at this texture here. This is just a sprite. Okay. Now let's see if we can make this into something that we can add vertices on, because you can't do this with the sprite. Can't do that. Okay. Let's look what this is. It's also just a sprite. And it's skinned. Okay. So let's try to do the same with our heart. Can we skin this? Yes, we can. So let's generate a geometry. And we might want to, we now can edit the detail, the outlines. And if we put subdivide to 0, it's only going to do this to the edges. I'm not sure why the developers of Unity did not apply vertices to the middle part. But it might be because it's a sprite that they thought it's not necessary. They can save some processing power. So let's let's copy that principle and do this with our heart sprite. Okay, I think these are enough vertices that we can apply this. And now nothing should happen. Let's look into the game. The heart is still working. Okay. Now we can start to edit our shader. And this is the shader that we are interested in. And there's a lot of other shaders. Let's read them out. Auto mask, background, unlit. What could this be? This is a yeah, this is this background. Okay. No, I'm not too impressed with the background. It's painted well. There's a fog effect, but aside from that, there's not too much going on there. I think the fog effect might be nice later. Caustic does not bring anything. Electric unit, this is the stuff that we pick up here at the end. This is the electric unit, and I think actually this shader graph is not as beautiful. It works in the game because you see it very small. I think it's one of the inferior parts of this demo. And we have this lit glyphs. It's very beautiful. A particle. And they have lit and unlit particles. Very standard, just for particle effects. Spirit, then for the spirits that you can see in the game later on. And the water. Oh, the water. Yeah, the water is also very interesting. Now, unfortunately, we cannot see this in the preview. But this is also a very interesting shader. Unfortunately, in our game, we do not have any water. But thanks to the shader graph, if I ever want to add water, and it's a good idea because it's just looking so good, I can just copy the properties of the shader. But aside from that, this is the only shader that is mattering for current tasks, which is moving the hotspot. So, as I said, I'm just going to take all of these nodes here, copy them, and then paste them into my game. And now I have them copy and pasted and can use them. I'm going to apply them. This is legacy. Let's update this. Okay. And I'm going to apply them. There should be something coming out here. Why does this not have an out? Convert to object. Now I should be able to put this inside of this vertex. I can't. This is the only thing that's not good at all. Yeah, let's just try to create another node. Transform. Now this transform has an out. drag this inside. I can connect this to our vertices. I don't understand why this node does not have an out. Because maybe it's vert to object. No, it still works. And there, aside from that, these are exactly the same nodes. At least from what I can read here. It's interesting. Might be a bug because of copy pasting. Let's hope this is a bug because of copy and pasting. So let's make this big. Can we have a preview? Preview. Yes, we can. So the heart is actually moving, but it's not moving as much as the 3 leaves that we just saw. So we have to adjust our settings right here. And I know why, because the all the floats that are defined here, like wind direction, wind strength, wind scale, wind direction, wind speed, we don't have these. We don't have these. So what I'm going to do is I will put this on my second will put the shader graph of last script, the demo of Unity, on my second screen, so I can read the floats that they have defined, and then I can copy them because I need them. Like now, this field here, this float, I have to set a public variable for that, and then later with the code I can change this variable. So let's go. So the first one is going to be wind speed. So wind speed. It is set to 0.4. This is going to take a while. Now we can drag it into here. If I change this, you should actually see more movement on the heart spot right there. Yeah, we do. And we see that the heart seems to be moving a little bit. And if we would just apply this to the game right now, we would also need to apply this to the heart spot under the filled heart, because there's 2 spots, the heart filled and the heart empty. We would actually, just by doing this, increase the quality of our game. Just by doing this. But we're going to make our adjustments later. We still have a long way to go. So with the wind speed was 1.4. Okay, next vector. This is the wind direction. This is a vector 2. And let's maybe rename this, because we don't have wind on our heart. So what do we call this? What do we call this? Maybe beat direction. Yeah, let's do that. Beat direction and beat speed. And I also have an idea how we are going to make it into a real beat later. And this will be pretty easy, actually. We are just going to apply a sinus or a cos or a sinus or cosinus to the wind speed, I guess. And then we can really have the heart pump and stop, pump and stop. Now the next one is wind scale. So let's name this. Wind scale is a float. And we are going to name this beat scale. Okay. It's going to be set to 1. Next one is beat strength. Also a float. Let's see what happens to the heart if we set this to a really high value. Ooh, okay, that's interesting. Okay, that's interesting. Let's not set this to 1. Let's not set this to 1. That's very interesting right there. That's how it's happening to our heart. It's not looking like a beat, but it's really interesting. Okay. Yeah, we're going to experiment with these numbers a lot. But I have a really good feeling about this because the first big worry that I had is that we will have a problem. Come on, set this to 001. Okay, the first worry that I had was that we would have a problem with copying the stuff from the demo version into the current version of my game. And since we didn't have a problem at all with this, because I've set up a lot of stuff before, yeah, it's just a drag and drop. This is actually pretty amazing. Now we have wind influence mask Y position. Okay, so let's name this beat influence mask Y position. And this is set to 4. This is set to 4. And I'm going through the demo. I think we have every vector set up. Yeah, that's looking amazing. So I guess, did I really not? Let me double check. I did not forget anything. Okay, let's save this. And the first thing that we obviously want to change is the strength of the beats here. Because right now we don't see any movement in the heart. Well, actually, the beat strength has been set to 0, but it's still not enough. I can see movement right here, but it's just some pixels. It's barely noticeable. So we have to increase the beat strength. Here, like that, for example. Now we could just, if the character gets hurt, I guess we could just set this value here to a higher value. And when the character is hurt, the heart is actually showing some kind of nervous pumping here. And this is not that what we are going to do. At least this would be a good plan B, just to increase the quality of the UI. But I think there's a better way. Let's first try to experiment with the values. So one problem that we have is that this will never be looking like a beat, because it's using a scale which is used which is set with this UV map right here. This is a random movement. And I want to try something out. This is if we take the last transform here and just multiply it a little bit, and let's see what's going to happen. Maybe it's going to multiply their positions with the position of the vertices. Let's see what happens now. Okay, it didn't work. Set this to 1. Yes, so if we increase these values, you can see that we can actually increase the size of the heart. So with this, we can actually pump the heart. So there's one little problem that we still didn't solve. The offset of the heart, the center of the heart sprite is around this point here. this HUD is not centered. It's not centered, and this can be actually very problematic because the scaling is maybe going to be looking weird. And what we want to do is not to manually scale it like this with a script or something. We don't want this to do manually. We need to do this over time. So what will I want to do? First I want to get rid of the strong movement there. I think I increased the direction. Let's set this to maybe 4 for now. So we have a little bit of movement, but not too much. So this would be your heart. It's not doing anything, just moving a little bit randomly. And now we are going to create a time node. And this time, with this time node, we're going to create another node. This is going to be multiply and an add node or clamp. Let's add. And we're going to first use sine time, put it into the add node. Don't do anything. You won't sine and cosine. So what's sine doing? The sine is going around 0. It's a sine. Sine is wave, and it's going to be 1. It's going to be 0, and then it's going to be -1, going back to 0. So with this sine, we can actually do a lot of amazing stuff. But we in our case, we maybe don't want to have our scale to be -1 because it's going to be 1, and then it's going to be -1 here, and we don't want to have -1 numbers. So can we read what the value is right now? I don't think so. No, but I assume this is if we add 1, I assume this is now 0, 1, and 2. This is now the sinus is going to start at 1. It's going to be then going down to 0, and then at the going to maximum 2. Let's multiply this with 0.5. Now it's going from 1 to 0. And now we are going to create a vector 3. Still not finished. So this is why I said even I can put a lot of nodes together to do something useful, but putting them together and having a lot of nodes doesn't say that it's actually much work. It isn't. And this vector 3 is just that we have control over it later. So now let's see. So it's going to be 0, and it's going to be 1. And it looks awful. Okay. Now what can we do? We want this to be starting at 1, and we are starting at 0.5 right now, and we want this. Okay, we don't need to start at 1. That's not what we care about. But we want it to we want it to scale from 1 to 2. So let's just create another node. Say add. Drag in this vector 3 component, and let's just drag add 1 to every of these vectors. Now we are starting at 1. The heart is not going into this awkwardly small state. And now we are pumping some blood. It's still not looking good. It's still not looking good. There's definitely more work and more nodes that will be coming up. This is a good starting point. So we don't need this vector 3 right here. Oh, if we don't use this vector 3, we can't say what we want to add to each vector, which we might want to do. Or do we? This is interesting. Yeah, I might keep this one because I might change something here. But let's first change how much this sprite changes its size. This is not realistic. Let's go for way less movement, like this. Like this, maybe. Now it should not go outside of the sprite. Okay. Okay, let's put it to 2, just so that we can see what we are doing a little easier. Now we still have a problem. We cannot change the frequency of our heart rate. To change the frequency, we have to adjust the time scale. Right now we are just applying sine time. And to actually do this, to change this, we have to create more nodes. I guess, who didn't think of that? So instead of strict up using sine time out of this time right here, we are plugging in time into the sine, and nothing should change right here. Nothing should change. Okay, and now we can actually create a new node, which is going to be multiply. Put in our time. And now it's going to be twice as fast. And if we want to have a heartbeat, maybe like 4 times the time. And if we are hurt, we're going to increase this to maybe really fast. Now we have improved this to have at least some kind of heartbeat. Now we can put up this, put back the scale. Okay. So the only thing that is missing right here is that it's increasing its size and decreasing its size, but it doesn't look like it's pumping. That's the only thing that is missing right here. And also later on, we want to change the frequency of the heart rate. So for this, we are going to introduce a new float, which is the beat frequency. Let me check how to write frequency. Oh, with a C, yeah, of course. Beat frequency. And this is going to be the multiplication that we are going to apply. So we can now set this to exposed. And exposed means that we can change this heart rate later with our script. So when we are taking damage, we can set this to 16 and have it pump really hard. And if everything is is calm, we can change this to 4, and it's going to look much more calm. So if we put this to 4, especially if it's at 4, it looks way too sloppy. This is not going to fool anyone into that this is a beating heart. We still have more work to do, but I guess we are making progress, and that is the only thing that matters. So we did add 1 to every. Hello. So the net imp is waiting with a party of 1. Thank you, the net imp. How are you doing?
The net imp. The net 6 wave.
Hi there. How are you doing? I'm well, thanks. How are you? I'm really fine. I'm doing a heartbeat sound with the Shadowgraph right now. And thank you for following. What are you doing? Did you just stream? And what did you stream? Is this for URP or HDRP? This is for the universal rendering pipeline and not the high definition rendering pipeline, the URP. Are you working with the URP or HDRP? Working on a compass HUD. Ah, interesting. Yeah, HUDs. Well, I'm also working on my HUD right now. This is actually, if I go into the game, this is the HUD that you can see right here, and I want to apply some kind of beating to this. So interesting that you are also working on a HUD right now. Interesting. I'm using universal rendering pipeline at the moment. Yeah, I used HDRP for a project some weeks ago. I actually did, when I show this, wait a moment. Did you see the dragon there? And you can actually do these animation in Unity and record them. But then you still have to use some chroma key to remove the background. But there is a way around this. You can record actually in Unity, but the plugin for that is not working with universal rendering pipeline. It's only working with the high definition rendering pipeline, and this is so annoying then, because I had all my materials for URP and then they were not working in HDRP. It's really annoying. But it's possible. So for the future, if I want to record anything and just have make a GIF and you don't want to have a background, yeah, now I can use my project that I worked maybe 2 days on, because even though it was if it would have worked immediately, it would have been a 1-hour project. Yeah, but I've done it. Though, yeah, what can I say? Yeah, the heart beating looks cool. Have you an idea how I did this? You might even have some if you know the Unity demos. Hint, hint. Then you might get an idea. There's even a possibility that you have seen these graphs before. I'm fairly new, so not. Okay, this is from the last script, Unity demo. You see this? And what I did is, you see in the Unity demo, these leaves are moving. And I applied this to the heart. So that I can now adjust the heart beating. And to be honest, how awesome is that to just drag and drop in some things. I can even make it look really weird here. Let's see. If I change this beat strength, let's see what happens. Okay, now that's looking horrible. So you can mess up this really quickly, but you have a lot of choices right here to make. Oh, let's see. Okay, let's put that back up. I still haven't modified all the variables that I can adjust right here. I can even change the direction of the beat by put this to 0 and put this to 40. Now you see it's beating to the top. And I think this is simply amazing. Let's put this to -40. And now it's trying to beat to the downside, south side. Yeah. That's not looking as good. But it's really interesting what this can do. And it's just in last script. This is the shader graph of the leaves. Here they are doing their normal mapping, their mission maps, and I don't know. This is something that they do. This is everything they do with their textures. I didn't have time to look into that. I just look at this and said, okay, I don't care. This is what they do with the vertices. Right here, you see the vertices. I had to set this up. For this, I looked at the sprite. It did go into the sprite editor and edited some vertices. Let's see this. Here, you see these are the vertices. Each one has a position, and the shader graph then takes these positions. This is why they are plugged into the vertex position right here and modifies them. And this is how you can actually see some movement randomly in the heart. I mean, how amazing is that? I mean, no one is going to say that this looks awful, or are you disagreeing? I don't think so. Only thing is, I want this to be centered. Unfortunately, I did not center the sprite, and I think the easiest way to fix this is to center the sprite. Yeah, let's do this right now, because this is going to be way too annoying if I don't center the sprite. Now, what am I doing here? Okay, let's close the sprite editor. That's pretty cool. Yeah, but I guess how did your compass look like in the end? Did you make some progress? What were you programming on your compass? Or did you only work on the HUD of the compass, maybe add some functions? The compass works as I need it. When you spin it, moves and keeps position. I added markers to objects in the scene as well. So if there's a marker and you get closer to it, it enlarges. Oh, interesting. So it enlarges on your compass HUD, or will you have some effect in the game that enlarges? And you get further away from it, it will get smaller. Oh yes, on the compass. Yes. Okay, that's what. So like just like let me guess, Skyrim, like a Skyrim compass. Similar. Okay, similar. Okay, I changed the pivot point, but it actually did not change anything at all. Interesting. Let's apply this again. Okay, let's look into the game. And I'm very disturbed by the fact that the sprite here is not offset. Should not be on this position right now because I changed the position. Similar. I don't really have a game, just a Unity project with things that I think will be useful in the kind of games I think I would create. Yes, so you're simply learning. That's not a bad idea. Also, if you're looking for a job later and you just did a lot of stuff, you can always bring that up. It's going to be really useful and have some experience there. There's also a lot of Unity jobs that you can apply to. I'm also currently working for someone who wants to do a Unity project, and you can get paid very well. That was my fault. Yeah, on the other side, if you want to do your own project and find some guys who are really into gaming and stuff, nothing is going to this is interesting. No one is going to keep you from doing that. Okay, we have edited our shader. Now it's doing that. That is absolutely disgusting. And so what's happening right there? It's just applying to the position, but not to the position of the individual vertices at all. And this is really bad news because it could mean that we might not be able to do what we want to do with our UI. Because I guess this is because this is a canvas object and I'm using the image component. I think sprite renderer does not work here. So what if I would, oh, this is the wrong one. This is the one. Okay, this would actually work. Now we have two hearts and they work differently. Interesting. The problem with this heart is it's not interacting with the layering of the canvas, which is actually a big problem. So I can actually change the order. Never mind that. I didn't notice. So I've put this to 0. It's behind his heart and all the veins. If I put this to 1, it's in 1. So both are not optimal. But at least I can put it at the right direction. And later I'm going to apply the on the effects. I can disable this one. On the heart underneath too. And they are both going to pump at the same rate. So underneath this, oh no, I still have a problem. Now I need to have a way to fill this and defill. Now before, with this, the good thing with this heart is I can just, according to your current health, use this bar to set the fill amount. Now with our new sprite here, we can't do that. Well, we can, but we have to do it in shader graph, and this is going to actually be a lot of work because I have no idea how I can do this. Okay, that was my fault. That looks slick. It's nice to hear. So yeah, I think if we can make this work completely, it will really look slick. But we still have to find a way to fill this hard sprite right here. So according to the damage that you take, that it will fill and defill. Let's go and that is also the reason why I was doing this with this image right here. Now, can I maybe make this work without the sprite renderer? Oof, I don't know. Simple? No. This is not going to do anything. Build. And it's not this. So I guess image does not give us the option to edit the vertices, because I guess image does not use vertices at all. It does not use vertices. Yeah, that might be it. So we will never be able to do this. We need to set up this in sprite renderer. So nice, we will have to work even more. Okay. But before we work on the fill functions, which are going to increase and decrease the amount of pixels that you see from according how much health you have left, we're still going to, well, not the animator, to use the shader graph right here and finish our heartbeat. That's the first thing that we want to do. So one thing at a time. Let's go and finish the heartbeat first. So weirdly enough, we see the heart wobbling around here a little bit. But in the game, we don't see any heart wobble. That's interesting. And also a little bit worrying. It's worries me a little bit. It should be possible. It is definitely using the positions of the vertices. So we can edit it. Let's just put this to 0. So now we should not have any movement except for our wind direction. Okay, we can see that it is moving a little bit. So everything is all right. We just have to adjust this later. Have to adjust this later. It just wasn't visible. Couldn't see that. But if we increase all the frequencies and stuff, it's going to work. Now we should be able, if we look at the graph here, I'm sure there's a way to do it. You'll figure it out, I'm sure. Thank you. BRB. Ooh, then this will be a long task. I think this will be the task for the whole day. Because I see a lot of problems here. This script here is editing the image component. And we will have to remove this component later. So this will cause an error. So, no time to waste. So set up the camera, because yeah, it should be much better. Okay, so that's our next task. I guess. Oh, my biggest task will be I need tea soon. My last drop of tea. Okay, I wanted to look at if we can manually set the parameters inside of Unity now, which is definitely the case. I think I can just now look at this parameters here. This is nice. This is working, but I cannot edit them. Why? Because Unity expects me to set them inside of a material. That's bad. But I think I have set this material up to be the shader for that later. Let's look at this. No, I don't want to edit this. Let's make a new material. We're going to use the shader graph that we just created with this shader graphs. Shader graphs, it is the health bar hard shader. This is the one. And now, if we apply this material, let's rename this to health UI build hard shader. So we know this is the shader for the hard if it is filled. Now let's drag this into the sprite. I'll just find it here. Here. Now if I search for it, can immediately find it. Now it looks like nothing changed, and that's correct. Nothing changed because I just copied the material. But now I can, inside of this inspector field, on the fly, change all the fields that we have set up. And I mean, how amazing is that? Let's try out what happens. Now it's wobbling a little more. That's nice. And we can, in the game, see how it is going to look without having to worry about too much about changing the values inside of the shader graph. It's actually not overwriting the graphs. Cannot fade though. Okay, we need to change this later. The beat strength. Okay, let's not mess up with the beat speed. I think this is fine. I don't know what these two do. Looks like these are leftovers that we don't use anymore. I think I will delete those. And I have to learn how to write strength. Because that's not correct. Now I have a nice idea. I think if I change the vertices, we can maybe just apply the beat to the outer vertices, but not the inner ones. Ooh, this is going to be so difficult. So let's go back to our shader graph. And let's take a look at this. We can put on the beat frequency so we can see a little bit better what we are doing. I think this the preview here works better because as a beat, it looks more like a beat, like as this one, because it is changing according to the pivot point. And here the pivot point is not centered. So let's first go back to the sprite. Let's go to the sprite and change the pivot point. I think it's better if we set the pivot point to be here. Let's apply this. And I'm also going to add more vertices. So when I did the auto geometry, I did not subdivide. Okay, but actually I want to subdivide now. So we have some nice inner sections of this heart. So now we have a lot of vertices inside of the heart. And this makes it possible that we don't stretch the whole heart right here. So I also have set up some bones here. And we can actually, if we preview this, we can actually, with these bones, not this one, we can actually stretch the heart a little bit into a direction. We do this. Oh yes, this is so much better than doing this with shader graph. If we, for example, do this, it's going to stretch. Then we can put this back up, back here. It's back here, and it's going to pump back. Can actually now, because we are doing this with the shader graph right now, we can actually do the beatment movement with an animation. And if we mix those two together, we will have an actual beat animation that is realistic. So that is complicated because we are now using two techniques and we have to match their speed somehow. This is going to be awesome. So we already have set up an health UI animator, I guess, but it doesn't do anything because I tried this a long time ago, but back then I didn't know how this is supposed to work. Let's try to add this. Oh, before I do anything fancy, I need to make sure that it's really working. We see that the heart is a little bit harder to control because I changed the pivot point. But it's standing at its lower positions now instead of the whole position. That will make it a little bit easier to make it realistic, because realistically the veins right here at the heart, they are staying at the same position. Later we're going to also have this empty heart. Going to disable that. I can put this full heart image behind the rest of the UI. And this is how it's going to look. This is how it's going to look. Now not the best because it's not because these veins are not moving with the heart. It's a little unconvincing. Ooh, oh no. That's inconvenient. So we have to make sure that the point where these veins are attached are the pivot point. So let's put this point to this position where the veins are popping in. This is the aorta. So our arteries are attached to this position. We apply this, and now we might be able to make this work. Yeah, but we have to be really careful with this. So the first thing that we need to adjust now is we cannot make the heart too big. Because if it's too big, no one is going to buy this. And I mean not by buying, but by believing. So I'm going to, inside of shader graph, decrease the size. And that's absolutely no problem. But this position right here. Let's see where the original sprite is intended to be. Enabling this image again. Okay, so they're supposed to be a little bit more at the top. Right here. This is how it's intended. And this vein right here, oh yeah, where I had problem to make it look good, you don't have to worry about it. Actually, you don't have to worry about it. This vein here will be behind the health sprite. So that's convenient. Because then we won't have to worry about this sprite here. So, but since we do a lot of changes, and this sprite type right here is confusing me a little bit, we're going to make this into a sprite, not an image. And we don't see anything. Why? Oh, it's actually there. It's not at the right position. So let's copy this, put that back in, and use this as a template. And now we have to match its position. So it's, I think it's the scale is weirdly very small. So if we just increase the scale, we should at some point match the original sprite, just like that. Okay, we can put this copy out of the game and put this vein into the background where it belongs. Yeah, this is what we intended to. I think this was at the top. So, we need to make more changes. I think it was like this. This has to be at order 1. The heart has to be on 2 because it has to be on top of it. And then we have this veins top. I'm going to copy this. And also apply a sprite render to this object right here. Let's put this to the foreground. I don't see it. Interesting, I don't see the sprite. Maybe because I use the default layer. Yeah, that would explain it. Damn it, but I don't want to scale the whole thing because I'm too lazy to set up the text again. So I'm just going to add a new game object. Call this veins top sprite. And this is going to have the sprite render component. And now I can only scale this component until it matches the size that I wish for. Put the text on top of it. Ooh, the text is not on top. It's a problem. But why? I think there are settings inside of the text component which can set up the layer. Yeah, okay. Can just put this to a really high number. So which order you are the 4 and I'm the 5. Or let's just say 10. Okay. Now we have everything in order and it looks all right. Now we can start with the hard part. Turn these veins, and I actually think I made a mistake there. These veins in the background, I can put them to -1. I think it looks much better if they are behind this blood UI. Okay, let's save this because we made a lot of changes and we don't want to lose that progress. So I think if we just keep this and don't do anything, we can close shader graph. Because it would be way much more clever to, because we are using a sprite right now, to just add an animation right there. So what do I mean? How do we add an animation to the UI? First, we have to make sure now, because we did a lot of changes, that this does not mess with the actual game. Let's change, first, or this is going to cause an error, because we disabled the images. And still we need to test if we can still see the heart in the game. So what's going to happen, or I expect to happen, now we are going to have an error because there's a script that is searching for the image of the heart, and we changed this from an image to a sprite. And this is why I'm expecting to have an error right at the start. Property multiply is changed. Okay. So if we play now, you can see that the heart right there is actually moving. And that's really, really nice. It's a little bit wobbling too much. We can adjust this later. This is just changing some values. But aside from that, that's really, really nice. The other sprites right there, they are not lit. They are too dark. You look at these sprites right here. Here. That's also easy to fix. We just have to give them a sprite. So how we do that? A material. I'm just going to copy this material here. No, this is not the material that we need. We'll get there. I'll find it. There's a lot of materials that use this. I think the ground here. It needs to use an unlit sprite. So if I use the lightning setting, I can see that these are not lit. Because now they are working with lightning in the game, and we don't want this. This is a UI. We don't want this to interact with lightning inside of the game. So we are going to set them to sprite unlit. And we're finished. Yeah, too easy. So let's not remove the image yet, because this is going to cause an error. Let's go and hit play again and look what's happening. So the only thing that is a little bit annoying is that the preview that we have in the game is different from the preview in the game. Because right now we see that the wobbling of the heart is different from what we have set up in the game. So I guess we have to apply other values. Aside from this, I think this is really, really looking nice. So now, what we need to do is to animate this heart. And we could try to do this more with shader graph and apply more changes. But what we really need to do is make the animation with some bones. The problem is in shader graph can extend, you can make this smaller, but it doesn't have any information how it should apply this to different bones inside of the vertices inside of the heart. We can only do this if we do this with the bone structure that we have just set up. So this is nice, this is fine, this is a nice addition to the heart and much more believable than what we had, but there's more. So first we need to make an animation. So let's go inside of this graph here And let's create the first animation. And let's call, we are already in the right folder. Let's call this heartbeat animation. Oh, heartbeat. It already has the data type anim, which will tell us that this is an animation. So let's apply our animations that we have set up. What this is? Health UI animation. Health UI, okay. And now we can try to find the bone. Oh, we don't have any bones. We don't have bones. We need to. This is interesting. Okay. We need to import the bones that we have set up here. Now let's look what happens if we import the sprite right here. Where is it? Oh, I think it applied it to some kind of UI element. Yeah, like this. No, it will not import the bones. Okay. Let's look at the player. The player has bones. And let's look how the player is animated. So normally I drag and drop these inside the game, and then it will set up the bones automatically. You have set them up before. Interesting. So we might have to change this. Okay, let's look into what kind of animation this is. So we have all these parts, body parts. This is a sprite, 2D and UI. And this head has a character rig. Okay, let's look into the health UI advanced settings. Find the source image. Let's see what we have set up here. And there's nothing that lets us define that we want to set to use the rigging. So we set this to polygon. No rigging. No. Okay. I need to Google this. So let's go. Okay, we can, this is the comment that we are looking for. Add this sprite skin script into it. Okay. That was fast. Let's try this out. And now we can actually create bones. Oh no, not to this one. This one. Okay, create bones. Okay, the art disappeared. I think what happened is because we changed the scale. I think this is because we changed the scale. I'm not quite sure. So we have these bones set up, but they are not at the right scale. This is a failure as an import. Also, the Z coordinate is weird. No, this is the Z co-rotation. That's right. So it imports these bones, but puts them to the wrong scale. I think it has something to do with this size, that is the width and the height inside of this sprite renderer. Yes, because this is, oh, this is sliced. Okay, now we have to readjust its total size. Okay, I see. I was trying out something there. Okay. Amazing. I did not think that changing the draw mode here would change anything with this sprite, but it did. So let's put it back to the center where it belongs. I think this is a right tight spot where the art looks good. Now we have two bone structures. That's not right. Let's rebind the bones. Okay, now yes, now we can make our animation. Okay, that took long enough. So let's add some animations. For this we are going to record. And we want to just make a heartbeat. So let's set this up to 0.3. And let's not rotate the whole sprite. That's not going to be a good idea. You can extend this outer part of the heart and give it another direction. Okay. We can also extend this part of the heart. Let it put out, go outwards. Okay. And before we do anything else, let's just go to YouTube. Let's heartbeat. Okay, we're finding songs. I want to find a real heartbeat. Real? What could we search for? Okay, this is realistic. Oh, this is a sound effect. This seems to be what we are looking for. Yes, this is what we are looking for. Oh, we can only see one part of the heart. Also, I'm not sure if this animation was correct. I think this is not correct, because both parts of the heart are moving simultaneously, and I think first the blood is going to pump into this part of the heart, and then this part of the heart is going to open and let it flow. So let's look at another heart. So this part here is extending. Okay, they show the cross section. And we don't care for the structure, we just want to see it pumping. Okay, this video doesn't focus on that. There. Now we can name everything. Upper chambers, lower chambers. And I think it was like this. It's first pumping inside of the upper chambers, and then it's going to pump into the lower chambers in a rhythm. And we have the valves. We don't have to animate with the valves. Valves, yes, valves. Sorry, it's wrong pronunciation there. Now let's see if we have a heartbeat animation right there. So let's analyze this. So first, this size is going to be inhaling, and then it's going to pump the blood around here. Ooh. This might take a while. And then we see an animation where the heart is just extending. Okay, I don't think this is a good animation. Let's find more animations for a heartbeat. Heartbeat animation. Unfortunately, when they focus on the inner parts, I'm more interested in how it looks from the outside. I think this is this right here. This is also the angle that we see the heart in the game. Okay, let's just try to do this. So what I saw is it's going to extract here. And then it's inhale at this part and then exhale at this part. So the root bone 2 is going to move into this. I bet this is not looking good at all, but we still have time. Yeah, it's a little bit too much. It's I think I'd like this part. Let's deactivate the bones. It's extending a little bit too much. It's also not the same rhythm as the animation. Okay, let's wait. Okay, the animation is two whole seconds. Okay, let's adjust it to 2 seconds. Okay, the rhythm is a little bit mixed up with the shader graph right there. I don't know what time the shader graph is using. Going to look at that because it's going to be a little bit annoying to try to find the rhythm there. Beat scale is 1. Beat frequency is 4. Put this to 1. It's going to be slower. We'll put this to 10. Why is nothing happening? Oh, this is the actual shader. What? Did I set it up to be another shader? But this was this one. Oh no, this is another shader. And this doesn't matter at all because I'm looking for the wrong material the whole time. This is the material I'm looking for. So if I put this to 8, it's going faster. If I put this to 1, it's going slower. The problem is, how slow does this go? I think right now it's like this. This is sine wave. And I think sine is making 1 beat in 1 second. And if it's set to, no, it's going to have its first part in 1 second until it comes back to 0. And then after 2 seconds, it will finish its part. Let's put this to 2. Is this 1 second? No. 1, 2. Okay, let's look up Unity sine. Shader graph. Sine. The sine node. How long do you need for one circle? And it doesn't tell us anything at all. So it's something around a phi plus 2 phi, so which is 3 phi. The period of the sine function is 2 pi. So this would be something like 6 seconds. Okay, so if we multiply this with 6 pi, like this, now it's going to take 1 second per heartbeat. Let's calculate 6 pi. No, sorry, 2 pi. Put this inside our beat frequency. Now this is going to take exactly 1 second to beat. And now we can match our animation actually to the beat frequency, because we now know that this is taking exactly 1 second. So let's rebind the pose. Okay, now we still see that the animation is not correct. There's a lot to do there, but we know that the frequency at least is matching the shader graph extension. The shader graph is extending and de-extending the heart, and now we can start to really animate that. So for this, going to this looks weird. Okay. Okay, this looks funny. It actually looks funny. So in the middle part here, it will have its full extension. And this will be the preparation. So what we want is for this chamber is to pump in some blood, and then this chamber here is going to extend, and then it's going to default again. Okay, let's play this from the start. Okay, I think this chamber movement is still very awkward, but we're getting there. Small improvements. And it's also because we were doing this already. Let's close the preview. Before we do anything else, let's make that we can actually change the beat frequency, but we want to change this to beats per second. So this will be useful for later. Later, I don't want to calculate into the calculator every time, like how many pi do we need for that many seconds, and it's going to be a little bit. Hey, of course, you can do it to show that you're a genius, but that's not going to be effective. We're going to adjust this, so the beat frequency is going to be multiplied with the 6 pi that we had there is 2 pi. Was it going to divide it? I don't know. Let's put this to 1 and plug it in here. So this should be 1 beat per second. 1, 2, 3, yeah. Now if I put this to 2, it should be 2 beats per second. 1, 2, 1, 2. Okay, and if I put this to 6, it should be like your heart is killing you. Yeah, okay. Now we have a new parameter here. We can rename this to beats per second. Okay, this will be just a little bit more convenient for later to set this up. The thing is, if we set up the animator and make this exactly 1 second, and we also know that the shader graph is going for each circle period for 1 second, we can just apply the same multiplication to both graphs if we are going to adjust them later when we're taking damage. When we're taking damage, we want the heart, of course, to be pounding faster. And to do this, we want to multiply them and set, for example, set them both to 2. And now, because they are all in their default state, doing 1 beats per second, now if we will put them both to 2, they will have the same weight. And with this method, we can actually get around doing some complicated math later. So this might seem unnecessary now, but this will really save us some time. So let's go again for heart and fix our weird pumping action here. Just by trial and error. Okay, I think in the start position can make this sprite be a little bit more inhaling. Well, let's put this to default. Okay, let's not push the bound down at this position. Hello, I only want to edit this bound. Okay, let's try to do that. Maybe at another timing. No. Yeah, that looks a little bit more like it. Like this chamber here is pumping blood into this chamber. Okay, I want to make this movement of the second chamber more sudden. Now I have an idea what could help us, because we're having a problem with the beats. So if we set this to 0, or we're still in an animation mode. Put this to the 0, it will not move anymore from the shader. Now we can actually see just the rhythm, the movements that we have set up with the animation, which is going to be a little bit more convenient, because working with both together is going to obfuscate a little bit what we are really doing there. Okay, now let's change maybe this part. Let's just strict up copy the bone position of left chamber. Now, is this realistic? No. What would actually happen? First, the upper chambers, these chambers here and here, would fill, and then the blood would flow into the lower chambers, this chamber and this chamber. So let's try this animation again in a little bit more realistic approach. So the first part is going to be the upper chamber is going to fill. So this part here is extending. This part here is not extending. Oh man. Want to go to, let's reset the start position. I only wanted to, come on. I only wanted to apply this to the first part of the animation. This is filling, this is chilling. Now, the second, and in the second phase, this is going to be in until this phase. In the second phase, the blood is going to be pumped into the lower chambers. Let's animate the left chamber, only the left chamber, and focus on one task at a time. So this is going to detract. This is going to extract. This is going to look a little bit weird. But you actually can see that it kind of looks more realistic just because we did real anatomy. And yeah, I like it much more. In the left part. Now let's go for the right part, which is the right chamber. So let's see the bones again. And in the first part, the upper chamber. We don't have any way to control the vertices of the upper chamber right now. That's bad. That's bad. If we change the position of this bone is useless. Damn. Didn't think of that. I do have some control. Just wasn't what I was thinking. With this slider right here, now this is going to make the upper chambers pump. I have to go back on the retraction here. And then we're going to fill the lower chambers. Okay, I think we're going over the top here with this chamber. Okay, let's look at the animation. Okay, we have to come back to the start position. And look at it again. Look at this position. The upper chamber, the upper left chamber, could extract a little bit more. Okay, now let's see what the big white lower chamber does. Doesn't do too much right now. Yet this position it basically does nothing. Which is right. It gets a little bit smaller though. Too, which is good. It's real anatomy. But I think it could even go a little bit more. It's not doing too much right now. And here, when it's extracting, no, let's try to let it point somewhere natural. Yeah, like this. Okay, let's go for it again. And I think we can even go more over the top with the lower right chamber. Not doing enough. Here at this position, you would see it being retracted really hard. Okay, now let's see what happens if we add both effects from the shader graph and the heartbeat animation together. So we are going out of preview mode, put beats per second to 1, and then play the time when this is the heart is at its smallest size. And this looks kind of disgusting. Okay, this is really interesting. Now it's not bad that it looks disgusting. It's really interesting. But let's see what the animator does. Okay, the animator only does one thing: set up the heartbeat right here. And we might want to add one state, which is dead. Hard dead. This might sound like a little bit of bad language like there. Like, okay, it's just that. You sure you want to make this a state? But the name is very self-descriptive, and that is the only thing that programmers care about. So let's add 2 triggers. Start beating. and die. And for this, we want to die. For this, we want to start beating. And we will also want to have a float with beats per second. And this will allow us, let's put this to 1 later, this will allow us to set this as a multiplier, and the speed is now multiplied with the animation speed is now multiplied with beats per second. So since speed is going to be 1, it's the same as if we would set this speed 2 beats per second. And in the scripts, we can now edit beats per second to increase or decrease our beats per second. Yeah, pretty much what you said. This is so we still have to do some coding later. Didn't expect us to do coding for the heart today. I really thought we could maybe do it just with shader graph. I don't know what I was thinking there. Now let's put back this health text right here is not scaled right. Could you please stop scaling weirdly? Oh. I see what the problem is. So I need to look at the gizmos and set the anchors to a better position. The anchoring was a little bit wrong. Okay, now let's save, because we did a lot of changes. And let's just hit play and look if this is working. It would be really nice. And what we see there is a really big heart. This is luckily not the heart that we are worrying about. The heart that we are worrying about is doing exactly what we want. So we now have a beating heart. We still need to do some coding stuff with it. And once we're finished, we can also change all this stuff later on and have some more artistic work on it. So I still think something looks odd with the current animation. I think it's because I think what's happening there is that the shader graph, the sine wave, is not starting at the same time period as the heartbeat, because the sine wave is going to start at, currently it's going to start at 1.15, no 1.5, then it's going up to 2, and then it's going down to 0 and coming back to 1.5. What we actually want the shader graph to do is to start at its maximum or minimum. Right now it's starting at the middle. This is why this heartbeat looks a little bit weird, because the shader graph is not synced up with the heartbeat. So how do we do that? And for this we are going to look at sine. So this is a sine wave. And we see that here at this point we start the sine wave. We have put this up. So our sine wave will never be in the negative. Our sine wave will never hit -1. It will start at 1. No, 1, 5. So we have to put this up in your head. And then it's going to hit its maximum, going down, and after 3/2 of a pi, it's going to its minimum. And we are starting our animation at this point right here, and we are starting the shader graph at this point. So what we can actually do is we add 3/2 of a pi or subtract 2/2 of a pi. So let's go do that. Let's go into the shader graph again, which I actually this time will find much faster. That's nice. And here, when we use our time component, and let's first make a new window with this because it's way too small. Okay, let's try to find our time component. Oh no. So we are doing some multiplication stuff beforehand. And then multiply that with time and then put that into into sine. How are we going to adjust this to what we actually want? Okay. I think what I naturally would think is put an add node right here and put in the time and multiply that. So what we are going to add, so that we start the sine wave at this time here. We need to add 2/3. And then we are multiplying this value. We have to add 2/3 of a pi. But then we are going to multiply this value. And then let's for example say we multiply it with the 1.1, then it will be somewhere here. It will not match what we actually want. So this is not right. This will not work. Okay. So we have to add it later. So I think what we need to do is we plug this back in, create a new node, an add node, create a new node, multiply, and let's multiply. Take the same multiplication, just like this, that we do in this node. Multiply the value that we will set up later. And then add those two together. And put them out into the sine. Now we don't see anything yet. Because this is just adding two values. And since we're using the same time stretching as the beats per second, it's syncing up. And now we can put in two-thirds of a pi right here. So let's go. Use a calculator. And put in 2/3 of a pi. How do we do this? 2 divided by 3 times pi. And here we get it. Now nothing seems to have changed, but it actually did change something. Now we are starting, if everything did go right, now we are starting at this position here. We added 2/3 of a pi. And hopefully it does what we think it would do. Oh, but did I do this right? No, I didn't. This is 3/2 of a pi. Okay. Let's go again. No. 3/2 times pi. Okay, this is the correct value. Whoops. Nearly messed up right there. Okay. Now, next thing is we want to, because we are using 2 pi here and here, we're going to make this one float. We're going to name this flow 2 pi. Can we do this? Yes. This is not going to export. We are not going to change it later. And its value will be 2 pi. Yay. No. Oh, no. Come here. I want to set you up into this multiplication. No. Come on. Where are you? Okay, I accidentally deleted it. That's not what I wanted. How did I do that? Sorry. And Control Z is really messing with Unity, I see. It's a little weird. Okay, and I don't want this multiplication load now to be inside of the visual adjustment to noise. Oh. So this not. But how do I get them out of there? Okay, just like this. Yeah, I think then there must be a shortcut, but I don't know it. Let's save the shader graph and play the game.
Plane.
Okay, let's change the position of this peasant right here because he's annoying me. Okay, I might close last script because it's not good to have two projects open. So I'm going to close last script. It's currently busy. That's not good. Okay, now we can change close last script. Don't save this because in the long term it's just using more resources, which even if you say, okay, my PC can handle it, it's still not good for your electricity bill, which is also not good for the environment. And aside from this, my PC needs every space on its GPU that it can have. Needs every resource. Okay, let's now just focus on the heart. Just focus on the heart. Okay. What changes could we apply? I say it first. A lot. Let's just go into it. Select the heart. Show its bones and start animating again. Oh, I think there was also another problem. Yeah, still have set this beats per second to 1. No, I didn't. Never mind that. So let's review the heartbeat and create a new clip, by the way, which is going to be where's the other heart animation. Let's search for heartbeat. This is something that I really find a little bit annoying in Unity. When making new animation, the folder it chooses to come on. It does not want me to do anything. Come on, let me change you. The folder that it's trying to put something into is sometimes really weird. Like it's just trying to put it into the current project or folder that you have opened last time, and in most cases it's not where the other animations are, and that's kind of weird. So Heart Dead is our next animation. So what's Heart Dead? It's when the heart is not beating at all because we have died in the scene. Right here. And now, oh, it automatically did set up the animation, the motion right there. That's good. So we're done. We're done with this. We only need to adjust our animation. And when we are done with the animation, we finally can try to make the code, and then we will be done with the health UI. So there's still a lot of code that we want to do with this heartbeat, but it's not the end of the world. It won't take forever. So what we want to do in the code is change the heart rate, for example. Now let's think for a second. Now, I think we will have to cheat in the end. Let's think about how the blood would flow. These are the veins where the blood would be arriving. They would fill up the top chambers. Then the blood would flow into this chamber right here. This chamber would push the blood. Now it's 2 circles. Oh no. This is so complicated. Let's look into hard animations again. Just look at hard animations again. No, not this one. See, this looks like a hard failure. Okay, interestingly, in this animation, the tip, I think this is called the hard tip, is not moving. Let's maybe search for real heart beating. But in this animation, the tip is moving all over the place. So one of these has to be wrong. Let's look for real heart beating. Because the animations are wrong. So, disclaimer, blood. Be careful, now I will show a heart beating. Ooh, disgusting. So I don't think we can learn anything from this. There, okay. Okay, there's nothing we can learn from this, except, and I'm really not confident playing more of this on stream. So yeah, let's maybe not try to be too realistic. I don't want to get a strike for showing how a heart moves. Even though I don't think it's going to anyone is going to complain. So I think this motion right here, this is very good. This is the good part of the motion. I like this. You really see that the heart is retracting. And now it's extracting. I think this is the part where it looks weird. I think maybe we did go over the top like there. And I would just want to find the right angles so that this does actually look good. Okay, let's see this in movement. Okay, now this is not enough. So it must be some middle ground. Okay, let's just make small steps and be settled with it. And this is where I really start to like the movement. Yeah, I think this is as good as it gets. This is really a good heartbeat. Let's try this in the game now. Let's save, because if we are saving, it's also saving all our animations, and hit play. And hopefully, this will be our final cut for the heartbeat. So after that, yeah. I think this is maybe sufficient, yes. Now I do have a small problem right there with the other sprite because it's overlapping. There's this sprite right here. This right here. I don't see where we did put it. The empty heart sprite is not at this at the right position. We shouldn't see it at all, I guess. Or should we? I think a script is enabling the image component. Let's look again. So if we hit play right there, click this heart. At some point we should get the heart image. No, we are not. Okay, then we have to guess. So is it this image? No. This image? Yes. I think this was enabled with the script. It was put back on immediately. Okay. Let's disable the health UI. Now it disappeared. Okay. And I think it looks good. Well, it's way better than having no heart movement at all. still not convinced that we are using shader graph to increase and decrease the scale. Let's try out what happens if we play the dev animation. Okay, dip 2. Oh, it did die. I did it in the wrong sprite though. Yeah, the shader graph is not pumping right now. For some reason the shader graph is not doing anything. Well, it is doing something because we're seeing the random noise inside of the heart. We still have to match the random noise with the actual heartbeat. So it's still a lot of work to do. But I do not understand why we don't see anything else in the heart right now. It also does not display anything in this view. So let's go into it. That's weird. Now we can see that it edits its vertices. So there is a slight wobbling inside of the heart. Yeah, we see that. But it's not increasing and decreasing in size. So let's look into the graph, I guess. The graph tells me, no, I am increasing and decreasing in size. Okay. The only explanation, aside from that, why this would be is that the animator is editing the vertices and overriding the shader graph component. So I can set this layer here to additive, and now it might work. No, that wasn't it. Or maybe if I set this, or I can't set a weight. Let's set it to dead again. Now, okay, I have an idea. Let's not play this in maximized. Let's do it normalized, normally, so it doesn't play this in full screen. Good. Go inside the animator and let it die. The problem is I think I see some movement. Yeah, it's still wobbling. So even though the animator is playing the dead animation, it's still applying the vertex changes. Let's see if we can, yeah, we can absolutely change the strength of the wobbling. Hmm. I mean, this is maybe a good time to set this up, because I have the feeling like currently we are not applying enough beat. Enough wobble to be visible. Hey, that's too much. I think this value is really weird. Okay, now we still have one problem. Our beats per second don't apply. And for this, I'm going to make a test. Let's disable the animator. Okay, it doesn't seem to. Oh, no, this animator. It doesn't seem to interfere with our vertices. What about its white skin and its bones? Also no change. Hmm. That's so weird. I don't remember changing anything that could influence this. Hmm. I'm going to restart Unity because I really don't know if there's maybe a bug right there. It should pump. It should pump. And on the other side, I didn't have dinner yet, and I need some new tea. So I guess this is a good time for a new break. After this, we are going to fix the heart rate to the heart, so that it will display the beat from its shader too, and then we will be finished with all the setup for the heart, and we are going to code how the damage that we do to our player is going to be displayed on the new heart UI that we just created. So be right back, see you then.